Welcome. Today we're diving into Node.js performance optimization. We'll explore various techniques to make your Node.js applications faster and more efficient, ensuring they can handle more load and provide a better user experience. Let's get started. One of the most important aspects of Node.js performance is understanding and optimizing the event loop. On the left, we see an example of blocking code. The heavy task function performs a very large calculation within a single synchronous loop, effectively blocking the event loop and preventing Node.js from handling other requests or events during that time. On the right, we have a non-blocking code approach. Instead of doing the entire calculation at once, we break it down into smaller chunks and use setImmediate to schedule each chunk to be executed on the next iteration of the event loop. This allows Node.js to continue processing other events while the heavy task is being executed in the background. Async/await is a powerful feature in JavaScript, but it can be misused and lead to performance bottlenecks. On the left, we have the sequential execution. In this example, each function call depends on the result of the previous one, causing them to execute one after another. If each of these functions takes 1 second to complete, the entire slow approach function will take 3 seconds. On the right, we have parallel execution. By using promise.all, we can execute all 3 functions concurrently. This approach significantly reduces the total execution time to approximately 1 second, as all the operations run in parallel. Efficient memory management is crucial for preventing performance issues and ensuring the stability of your Node.js applications. On the left, we have memory leak. The add-to-cache function continuously adds data to the cache object without ever clearing it. Over time, this will cause the application to consume more and more memory, eventually leading to a crash. On the right, we have proper cleanup. Instead of a simple object, we use the Lrucache library to create a cache with a maximum size of 500 entries and a time to live of 10 minutes. This ensures that the cache doesn't grow indefinitely and that stale data is automatically removed, preventing memory leaks. When dealing with large files, loading the entire file into memory can be very inefficient and lead to performance issues. On the left, we have loading all data. The processFile function reads the entire file into memory using read_file_sync. This approach can quickly consume a lot of memory, especially when dealing with files that are 1 GB or larger. On the right, we have stream processing. Instead of reading the entire file into memory at once, we use streams to process the data in chunks. This approach allows us to handle large files efficiently without running out of memory. Database interactions are often a major bottleneck in Node.js applications. On the left, we see M+1 query problem. The getUsers function first fetches all users from the database. Then, for each user, it makes a separate query to fetch their posts. This results in one query to fetch all users, plus an additional queries to fetch the posts for each user. On the right, we have optimized query. By using joins, we can fetch all the required data with a single query. This drastically reduces the number of database calls and improves performance. Caching is a powerful technique for improving the performance of Node.js applications by storing frequently accessed data in memory. On the left, we have no caching. The getExpensiveData function fetches data from the database every time it is called. This can be very slow if the data is expensive to compute or retrieve. On the right, we have Redis caching. Before querying the database, we check if the data is already in the Redis cache. If it is, we return the cache data immediately. Otherwise, we query the database, store the result in the cache, and then return it. Node.js runs on a single thread, which can become a bottleneck when performing CPU-intensive tasks. On the left, we have the main thread. The runWorker function creates a new worker thread and passes it some data. It then listens for messages from the worker and resolves the promise with the received data. On the right, we have worker thread. This code running inside the worker thread receives data from the parent port, performs a heavy computation, and then posts the result back to the parent port. Monitoring and profiling are essential for identifying performance bottlenecks and optimizing your Node.js applications. On the left, we have memory usage. The log memory usage function logs the current memory usage of the Node.js process. This can help you identify memory leaks and other memory-related issues. On the right, we have performance timing. The measure performance function measures the execution time of a given function. This can help you identify slow functions and optimize them. Let's summarize the key takeaways from this video. Use async/await and avoid blocking the event loop. Implement proper caching and avoid memory leaks. Process large files with streams instead of loading all data. Avoid N+1 queries and use proper indexing. Offload CPU-intensive tasks to worker threads. Continuously measure and optimize performance. By applying these techniques, you can significantly improve the performance and scalability of your Node.js applications. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.